Okay, so continuing talking about function composition, a function within another function, and simplifying it and talking about the domain of that stuff too. Here are some exercises I would like for you to try. So here you don't have to worry about domain. I just have two functions for f and for g, and I'm just working with numbers. I find one function, get an answer, take that, and I put the answer into the other function. So give those four a try. Go ahead and pause your video and then come back and check your work. All right, we got it? So let's see, are these the answers that you got? So on the first one, it's g composed with f of x. So or f of 5. I find 5 in f of x, get an answer, and I stick that answer into the g of x function, and I get 98. On the second one, it's the opposite of that, or the reverse of that, I should say. F composed, there's where it looks like it says fog. F composed with g of 5. I take 5, put it into f of x, get an answer, take that answer, and stick it into the g of x function. I get 142 when I simplify. And notice that if I switch the order, I get two different answers. This means that function composition is not necessarily commutative, right? Okay. And then a little bit weird, I took f of 5. So in other words, you stick 5 into the function f, get an answer, and then stick that answer back into the function again. You get 13. Do the same thing with the g of x function. G of phi, get an answer, stick it back into g, and you get 5,000. Interesting. Okay, so on exercise 7b, now you do have to worry about the domain. So this is not just the number part, it's the actual equation. What is the equation you get from doing the composition in the orders I give you on this 1, 2, and 3? And then find the domain of each new function, each composition. So pause that, give that a try, and let's see if you can figure those out. All right, what'd you think? Let's take a look here. Here are the answers. So on the first one, it's f of x is going into g of x. F of x is the interior function. So when I simplify that, I just get x over 4. I can leave it as x times the 4 times x to the negative 1 power, but it's easier to think of x, 4 over x plus 7. Okay, and then as far as the domain goes, I take the interior function, which is f of x. I would say it is x is not equal to 0 as long as the range, y is not equal to 0, is completely contained within the domain of g of x, which is all real numbers. And it is, so it works out.
Students and teachers, could I have your attention,
Just a second.
please?
Okay, and on number 2, so here I'm reversing the order essentially. G of x is the interior function, and it's going to go inside of x into the f of x function. Whenever I simplify, I get 2 divided by 2x plus 7. And so as far as what is the domain, I go, here's the interior function's domain, which is all real numbers. That's what I want it to be, as long as its range, which is also all real numbers, is completely within the domain of the exterior function. But the exterior function doesn't have 0 in it. So that means that I have to go back up here and figure out what is the x value that gives me 0 as an answer. So basically, that's what we were doing before with like rational equations and trying to set the bottom not equal to 0. And so I get x is not equal to negative 7 over 2. Okay. On number 3, it's f goes back into f. And this one was a strange one, because whenever you do this, you just get x back. What happens whenever you do the composition and you just get x? This means that they are inverses. Remember that? And essentially that function is its own inverse. You just get x as your answer. Now as far as the domain goes, I went ahead and I wrote in green here the domain of f of x again, so it's easy to go, oh, I would pick x is not equal to 0 as long as this range is completely in here, and it's exactly the same thing, so x cannot be equal to 0. All right. One more to tag along with that on exercise 8. Now I'm looking at some graphs and trying to do some compositions and function ops with it. So on the first one, I'm trying to find f of 1 plus g of 1. f of x is the bottom graph, and g of x is the top graph. f of 1, just follow it down, I get the number -1. So that's equal to -1. Plus, now g of 1 from the graph, go over to 1, go up to the g function, and I get 2. -1 plus 2 is 1. This is the kind of thing that's you sometimes see on an SAT test. Okay, so we're going to do something similar on number 2. So f of -2, -2, go down here, it's at -2, minus g of -2, so -2, go up to this one, and it's at 1. That gives me -3. Okay, now I'm going to do a division. F of 0 is -1 divided by g of 0. G of 0 is 0. -1 divided by 0, undefined. Last one, a composition. Tricky, perhaps. So I'm finding f composed with g of 1. So I first want to find the interior one, and that is g of 1. So g of 1, follow it up here, and I get 2. And then I want to find f of 2. So go to 2, and f of 2 is 1. It has nothing at all to do with that original input one. It's just completely coincidental. All right, that wraps up this objective. The next, no, it doesn't, tricked you, as Rowan would like to say. Okay, we've got one little extra part on this function decomposition. Decomposition is basically what we were doing, only backwards. I have the answer, and I want to break it apart as two functions that whenever I did do the composition, that's the answer that I would get. It's called decomposition. So take a look at this h of x function. H of x is equal to 2x minus 3 quantity squared. I can break this up as two different functions. Look at the one that's just inside the parentheses. I can see that as a function, 2x minus 3. Let's just call that g of x. Okay, in order to make the h of x function, that one has to be squared. So on the outside, the exterior function is just x squared. So the decomposition then would proceed in this order, that g of x has to be the interior function, and then f of x is the exterior function. Sometimes there's more than one way to do this. You just have to figure out one of them. Or maybe I might ask you two different ways to do it. Who knows? So that's what we're doing here. Let's write these as this. Find the decomposition. Write it as the composition of two functions. So here's one way to do this. What if I just take this whole top and go, hey, that's one of the functions. Let's say that's f of x. F of x is equal to the cube root of 8 minus x. Okay, so then I tried to imagine like that as being a whole in the original, like the g of h of x function, and what would that look like? So g of x, I'd have a blank spot over 5, so it's just x over 5. And then this function would have to go in there. So h of x would be composed of, the exterior function is g of x, and f of x is going inside of it. Okay, so there's one possible answer. Let's do this one other way in blue here. What if I just said the interior function is just this part right here? So f of x is equal to 8 minus x. Think of that part as being a whole, and what is the exterior function that's left over? Oops, here we go. G of x is equal to, I would have the cube root on top, so the cube root of x over 5. And this thing would have to go in inside the g of x function. Hey, there's the bell for class. And h of x would be composed of, g of x is still the exterior, and then f of x is the interior function. So either one of those would work as possible decompositions of h of x. All right, so that's it on this one. Last video is an extension of this whole lesson. It's on difference quotients, and it's pretty interesting stuff.